Our next endocrine organ is the thyroid gland. The thyroid gland sits on the anterior aspect of the trachea. There are two lobes to the thyroid gland, and they contain both follicular cells and parafollicular cells. Follicular cells make up these thyroid follicles. The parafollicular cells sit in between the thyroid follicles. And then, of course, they have a good blood supply. The follicular cells produce two hormones. One is called triiodothyronine, the other is called thyroxine. Triiodothyronine, T3, and thyroxine, T4, make up what I typically call thyroid hormone. Thyroid hormone can only be produced with iodine. So if you are low in iodine levels, you won't be able to produce your thyroid hormone, which means you have to have an iodine containing diet. So think about where you get your iodine from, and then think about if you believe that people in the U.S. typically have to worry about iodine. I'm going to leave it at that, and if you are confused or if you're not sure of where you get your iodine, ask, because it's something that's interesting that we can talk about. So what does thyroid hormone do? It maintains your metabolic activities. All of the catabolic activities, breaking stuff down, and anabolic activities, building stuff up. It does these things. So it helps to maintain our metabolism. And in doing so, it increases heat production. It increases calorie burning because we're constantly using energy to build stuff or break stuff down. And so here is an example of thyroid hormone at work. So first of all, we get thyrotropic releasing hormone that stimulates the anterior pituitary to release thyroid hormone, thyroid stimulating hormone, which is going to then stimulate the anterior pituitary to produce thyroid hormone. Thyroid hormone is going to enter the blood when we have low thyroid levels, of course, and that's going to activate metabolic activities, anabolic and catabolic activities depending. So you're going to break down glucose more effectively, break down fats more effectively, use sugar to produce new molecules, use sugars as the energy for the neurons as a main function, increase respiratory rates, increase heart rates. All of this is going to be an increase of the metabolism. Whoa. Sorry, I didn't mean to move the slide before I was finished. This is controlled by negative feedback. So here you see the stimulation. Hypothalamus stimulates the anterior pituitary, which stimulates the thyroid gland. Then when we have a lot of thyroid hormone, that's going to move to the hypothalamus and to the thyroid, or into the anterior pituitary, and inhibit the releasing hormones, the activating hormones. This is an activity called negative feedback. You need to remember positive and negative feedback. We talked about it last semester. We'll talk about it this semester. We'll talk about it all the time. This is how we maintain homeostasis. The parafollicular cells, so these are the cells in between the follicles, produce a hormone called calcitonin. Calcitonin is secreted when we have high blood calcium levels. And what it does is it stimulates osteoblast activity. So do you remember what osteoblasts do? Think about it for a second. They're little baby bone cells that produce bony matrix. So they're going to form bone and take calcium from the blood building up our bones. This is more often seen in children than in adults, because if you think about it, the last time any of you were probably told that you had high blood calcium levels was never. We never get told we have high blood calcium levels. Usually we're told, hey, we need to take more calcium in. In children, they're producing their bones, they're growing, and so they might have excess calcium in their system, and calcitonin can be released to help build bones up. But in adults, we don't really have that problem. On the back side of the thyroid gland, if we were to take the thyroid and flip it, you'll see between 4 and 6 tiny little structures called parathyroids. So you can see them right here. Here's 1, 2, 3, and 4. Parathyroid glands produce one hormone called parathyroid hormone, or PTH, and PTH functions to decrease or to increase calcium levels when we have a decrease in blood calcium levels. So it works in antagonism with calcitonin. If we have too low of blood calcium, then parathyroid hormone gets activated and is released and causes bone cells to break down. So it activates osteoclast, or bone breaking cells, the bone macrophages, to break down calcium, break down bone, releasing calcium into our system. It also, when we have parathyroid hormone, we increase the amount, or we activate vitamin D production, calcitriol, and that decreases urinary excretion of calcium and increases digestive absorption of calcium. So we increase blood calcium levels back to where they're supposed to be. And so here is a cute little figure that I found. Here we have high blood calcium levels. That's going to stimulate the thyroid gland, the parafollicular cells, to secrete calcitonin. Calcitonin causes our body to build up bone. That's an anabolic activity. And we go back to normal blood calcium levels. Negative feedback. We took some parameter that was moving away from homeostasis and we brought it back. Here we have low blood calcium levels. Flip that thyroid over and we have our parafollicular cell, or I'm sorry, our parathyroid cells, which produce parathyroid hormone. This hormone causes bones to break down. So this would be a catabolic activity, and calcium levels in the blood increase back to normal. And again, we start with some parameter. Here's homeostasis. Starts moving away from homeostasis and we just push it back. Negative feedback. I'm going to let you watch this video on your own so I can get to the next organ, or to the next information. So we're going to talk briefly about some disorders associated with our thyroid gland. Hyperthyroidism is a disorder associated with excessive production of thyroid hormone. These are some, it's a cartoon, but it shows true symptoms that you have with hyperthyroidism. So you're increasing your metabolic rate to such an extent that you actually lose weight. You may become hyperactive. You're going to be super hot because your body is producing so much heat. Your eyes can actually start to bulge out. You can see it here really well. That's known as exophthalmos. Typical treatment for severe hyperthyroidism is going to be removal of the thyroid gland. And then you'd have to have supplements. Hypothyroidism is the opposite. This is what we mostly see as a disorder. So we have decreased thyroid hormone production, which leads to low metabolic rate, a feeling of fatigue, and you're more cold, you're not producing as much energy. You may end up gaining weight, and often this can be caused by either the thyroid gland not secreting properly, or because you have a decreased amount of iodine in your diet. So remember, thyroid hormone can only be produced when we have iodine in our diet, and we get iodine in our diet from something. But I didn't want to tell you because I'm hoping you guys all know. A goiter is any enlargement, so a pathology that causes an enlargement of the thyroid. So here we have a goiter, and here we have a goiter. Both of these goiters are caused by different disorders. An endemic goiter, that's this one over here, is typically seen in iodine deficiencies. So we see these in developing countries where iodine is not commonly taken in to the diet. And with these, with this disorder, what happens is you're going to stimulate the thyroid gland with thyroid stimulating hormone because you have low levels of thyroid hormone in your system, and that increased stimulation causes the thyroid gland to get larger and larger and larger. But you can't produce thyroid hormone without iodine, so you're not producing the thyroid hormone, even though you're stimulating the thyroid gland to produce the hormone. It can be very painful, and you're going to have all the side effects of hypothyroidism as well. Toxic goiter, or Graves' disease, which is what we see here in this female, is associated with your immune system attacking itself. So this is a disorder where we have antibodies that attack our thyroid gland. They mimic thyroid stimulating hormone activity, and they continuously stimulate the thyroid gland. But in this case, we have enough iodine in our diet, so we're overproducing thyroid hormone. We're going to have very little thyroid stimulating hormone because we have so much thyroid hormone in our system. This is going to lead to hyperthyroidism effects. Does that make sense to everybody? So we have endemic goiters and toxic goiters. This is an autoimmune disorder. This is typically seen in a nutrient deficiency or iodine deficiency. With toxic goiter, I will mention that treatment is typically removal of the thyroid gland because you can't get rid of your antibodies, and then thyroid replacement therapy for life. With endemic goiter, adding the iodine back into the diet, removal of the excess tissue, and then maintaining the levels of iodine in your system so you can produce the hormone when you need it. Okay, we're going to stop here. We have two more organs that we will talk about, but I want to start a new recording with the next organ, which is our adrenal glands. So get ready for some exciting adrenal activity.